Hi guys, welcome back to another tutorial. So, have you ever wanted your Raspberry Pi to understand what you're saying in real time? So in this video, I'll show you how to run a speech to text on a Raspberry Pi 4 using Whisper.cpp and a USB microphone. So, to start, I want to talk a little bit about the objective of this project. So this project aims to turn a spoken audio into text in real time, and I'll be running on a Raspberry Pi 4. This does not require any cloud, no internet processing, and overall it is just a fun study project. So for the materials, I have here a Raspberry Pi 4 Model B. I have a USB microphone I got very cheap from Amazon. And also you need a micro SD card and a micro SD card reader. And for this project, I'm using a female HDMI to a male VGA cable because my monitor doesn't have a an HDMI cable port. So yeah, and also obviously the power supply, the monitor, and the keyboard and mouse. So the software that I'm gonna be using is Whisper.cpp, and it is an absolutely free and open source that everyone can use. So how this will work? So first, you will record your audio to a microphone, and then Raspberry Pi will process that audio using Whisper AI to turn that model into text. So to go another level deeper into the AI model, I want to talk about how this model actually works. So your voice is being recorded into the microphone, right? So Whisper AI, it converts that raw audio into a spectrogram like this. So spectrogram is basically just a speech pattern that is being recorded. And next, that audio is being moved to another layer, and this is called, I don't know how to spell it, how to say it. So it's 2x con v1d plus gel u. Again, this whole thing is on the Whisper AI official website. So this layer clean up the raw audio and it extract the important pattern while reducing the amount of data that is being processed. Next up is the encoding layer. So that audio is then being analyzed through a sinusoidal positional encoding. So what this does is that it slices up every piece of data and kind of mark the position, mark the numbers on it. So you see how, let's say, the sky is blue. So you notice how the stands before sky, and sky's before is, and is before blue. So this is where kind of changing all of the inputted data into an appropriate position. And the next one is the encoder block. So this audio, then the AI model then trying to interpret, to analyze, and get the meaning of it. Because again, this AI does not output of what is being inputted directly, but it has to understand the context of it. So what this layer does is that it's trying to understand, what are you talking about? What is the context behind this? And next up is the output layer, which is called the cross attention decode. So all of this does is that it lets the decoder to look at the encoded audio for precise word, because you know how you see this, the quick brown. So this decoder will decode the audio based on the encoder block, which it has to understand the meaning of it. So this cross attention makes them to go back and forth and the data flow so that they understand the context that is being outputted. And the last one is tokens. So you see at the bottom here, you say SOTEN transcribe and 00. So what that does is that this AI model it has only one version. So let's say if you do a Spanish version of it, an English version of it, a Vietnamese version of it, it is all the same model, but it uses these tokens to identify of which part of the model is being used. So SOT means that it start transcribing. EN is the language, and transcribe is when it start transcribing, and this is just a time stamped. So now you know how this model works. So first thing first, you gotta install your OS on your Raspberry Pi. If you just bought a new one, then I'll show you how to install an OS. And if you already got this OS installed, just move on to the next steps. So first thing first, click on your Pi that you're using. So right now I'm using a Raspberry Pi 4. It is actually a Model B. Yeah. So you click next. And here I make a big mistakes on choosing 32-bit. The time I was doing this because I thought 32-bit is lighter than the 64-bit, so it will run faster and more efficient. But no, it's not. This tutorial only works for 64-bit OS. So click on this, click next. Then I don't have a micro SD card reader right now, but basically you just put your micro SD card to the reader, and then it will read. And then you can do all kind of customizations. You can do hostname, localizations, user. You can even change the password, the Wi-Fi, remote access. And when you're done doing that, I'll suggest you to do another important steps. So just go on to your terminal. In my case, I say terminal, but most of the case, it's command line. So because you know how it is very hard to do all your things like troubleshooting, like searching things up or even typing on a Raspberry Pi, especially if you have like a shitty keyboard or mouse. So yeah, so I'll show you how to do a remote access on your Raspberry Pi. So first you do SSH and you want to type in the username in my case is tri at raspberry pi .local. So it will ask you for the password that you just set up or just install. So I'll type in my password. Oops. See, so now I'm connected to my Raspberry Pi remotely. And just to take note, this is only a access through the terminal. It doesn't have the full access to the Raspberry Pi itself. And in order to do that, you have to do it another way, which is VNC. And I think for this project only, I think SSH is pretty good on itself. So all you can do, you can list all the files. You can do a little update. Turn on everything is up to date, and sudo apt apt upgrade as usual is like a habit to do that every time I work on a Raspberry Pi. Just to make sure that everything is up to date, all my dependencies, because an out of date dependencies can lead to a lot of issues. And just the simple steps, just go through of like what libraries, what dependencies are missing, and make sure it's everything that is up to date. So when you have already updated your Raspberry Pi, you now want to check if the USB microphone is working or not. So first you plug, I don't know if you guys can see it. So this is my USB microphone, and what you want to do is that you want to plug it into one of the USB ports to see if it's working. So next up you do a record space /L to list all the recording files. So let's see. So this my microphone USB is in card number 3, and it is a USB audio. So you must remember your card number because this is going to be very important later. So in order to execute the model for this particular project, we have to install CMake. So you do sudo apt install /y CMake. So I already have it installed, so I don't need to. Next up is you have to install SCL2. Do the same thing, sudo apt install lib. Same thing, I already have it installed. So next up, you want to check what version your CMake is. You do CMake /s version to check is it the newest version. So mine is 3.31.6, which is the newest version. So next you want to clone the repository on GitHub. So I'll post the link below, so you just clone it from GitHub. So using the link below, I want you to clone it, the repository on GitHub. So this is a official GitHub repository by Whisper AI. So you do git clone and the link. So I already have it installed on my, downloaded on my Raspberry Pi. So next up, you want to see if it's installed or not. So you list all the files. And then you see, we just install Whisper.cpp.git, which is this folder. So you want to cd to that folder. So now we're in that folder. Yep. And next up is the model. As I said, there is a various model size. So Whisper.cpp offers model sizes from tiny, small, base, medium, large. And for my Raspberry Pi, and I think it'll be the same for other Raspberry Pi version because it is a small computer, so it won't be able to execute a large model. So what I recommend is to install the tiny, small, or base model. So here I'll use the base model, okay? So just wait for a sec for it to install, and we go from there. So after you're done downloading the model, the next step will be to build the Whisper.cpp using CMake. So here's the command. And again, all of the command that I use in this video will be posted down the description. So here, it might take a while for it to install, but I have already done this before, so it took me not a very long time. So okay, so now that you have built your model, it's time to execute the code. So very simply, you do build bin whisper stream, then you find your model. So the model that we use in this tutorial is base model. The step before, the length of 8, C0 slash T4 slash AC 512. So what are these flag means is that, actually I'm not pretty sure here. This is from a discussion of the tutorial, and I'll be posting the link below. So basically it tells you what all the flags mean. So for instance, the step of 4000 is that the auto step size in 4 milliseconds, meaning that it will transcribe every 4 seconds. The length is the audio length in millisecond. So I set mine to 8 and my step to 4, and I find it working pretty well. And also the C tag, T tag, and AC tag. So let's run it. So as you can see here, they have found a capture device, and C is your capture device. Remember the one that we did a record, the command at the start of the video? So that is where you put it in here. So you found one capturing device. This is very important, and if your model is not locating is not outputting any transcription, that may be that you have put in the wrong destination. So make sure that the Whisper model size have some number to it, because what I did in the past, I put it in the wrong bin, so it turns out not working. So now I'll do a quick demo of the Raspberry Pi speech to text. First build it, and I'll quickly choose a random speech that I found online. Let me see. Here. And all those watching an Obama speech, okay? Here. Found an random Obama speech. And you'll notice that transcribe every 4 seconds, and I'll count with you, okay?
Tonight from beyond our shores, from parliaments and palaces, to those who are huddled around radios in the forgotten corners of the world, our stories are singular, but our destiny is shared. And a new dawn of American leadership is at hand. To those who would tear the world down, we will defeat you. To those who seek peace and security, we support you. And to all those who have wondered if America's beacon still burns as bright, tonight we've proved once more that the true strength of our nation comes not from the might of our arm.
So basically you see that it's working pretty well. And I think the transcription works pretty well with this base model. But again, honestly, I think that base model is a relatively big model comparing how limited my Raspberry Pi is, because just 5 minutes earlier I was troubleshooting because my Raspberry Pi was getting throttlet, and it was getting overheated, and so I've tested out several models, including the tiny model, the base model, the small model, and I think the one that works the best is the tiny model, which I am using it as my main model for my ISP project. And I hope that you guys enjoyed this tutorial. And if you guys have any questions, just drop that below. And stay tuned for more tutorial. Goodbye.